Hello students, welcome to today's lecture on theory of machines. This is the part 2 of the lecture on differential band brake. In part 1 of this lecture, we discussed about the construction details of the differential band brake and learned about the direction of force applied in case when the distance A is greater than B and when A is less than B. We also discussed about the factors on which the effectiveness of the force applied depends, namely the direction of rotation of the drum, ratio of lengths A and B, and the direction of applied force. We further discussed the first configuration of differential band brake in which the distance A is greater than B and the force is applied in the downward direction on the lever. We derived the equation of force applied both in case of counterclockwise rotation and in case of clockwise rotation in this configuration and learned about the condition of self-locking in case of clockwise rotation of this configuration. That is, if A is greater than B and force is applied in the downward direction on the lever and drum is rotating in the clockwise direction, and if T2 by T1 is less than or equal to A by B, then the brake will be self-locking brake. In today's lecture, we will discuss the second configuration of the differential band brake and try to derive the relation for the applied force. We will also analyze whether this configuration will be self-locking or not. If yes, then what will be the condition of self-locking? We will analyze the configuration both in clockwise and counterclockwise directions. So let's start with the second configuration of the differential band brake, that is when the distance A is less than B and the force is applied in the upward direction on the lever. Force P is applied in the upward direction, then in that case this portion of the band will be lifted upwards and the band will be tightened and the brake will be applied. If the force is applied in the downward direction in this configuration, then the band will be loosened and the brake will not be applied. So let us first see the counterclockwise rotation of the drum in this case. So when the drum is rotating in the counterclockwise direction, then this side of the belt will be the tight side having tension T1 and this side of the belt will become slack side having tension T2. Now this will be the free body diagram of the lever having forces P, T1 and T2 again. Now taking moments about the fulcrum point O, we have T1 will be rotating the lever in the anti-clockwise direction. So it will have a positive moment with the magnitude of T1 into the perpendicular distance A. And P will also have an anti-clockwise rotation. So it will also have a positive moment with the magnitude P into L. But T2 will be rotating in the clockwise direction. So T2 will be having a negative moment with the magnitude T2 into P. So the moment equation can be written as T1 into A plus P into L minus T2 into B is equal to 0, where P and T1 are having positive moment and T2 is having a negative moment. So from here we can have the value of P as T2B minus T1A divided by L. Now here also as T2 is less than T1 and B is greater than A. So this brake will be effective as long as T2B is greater than T1A or T2 by T1 is greater than A by B. So this brake will be effective as long as the ratio of T2 to T1 is greater than A by B. Now what will happen if T2B will become less than or equal to T1A? In that case P will be either negative or 0. So the brake will be self-locking brake. So when T2 by T1 is less than equal to A by B, then P is 0 or negative. That is, the brake becomes self-locking as no force is needed to apply the brake. Once the brake has been engaged, no further force is required to stop the rotation of the drum. So in case of A is less than B and P is acting upwards, if T2 upon T1 will be less than or equal to A upon B, then this configuration of the brake will be self-locking brake. So moving ahead with the clockwise rotation of the drum. When the drum is rotating in the clockwise direction, so this side of the band will become the tight side and this side of the band will become the slack side. The tight side is having the tension T1 and slack side is having the tension T2. This will be the free body diagram of lever in this case, having forces again P, T1 and T2 Now taking moments about the fulcrum point O, we have T2 will rotate the lever in the anti-clockwise direction, so the moment will be positive and the magnitude will be T2 into A. Similarly, P will be also rotating the lever in the anti-clockwise direction, so the moment of P will also be positive with the magnitude P into L. But the moment of T1 will be negative as it will be rotating in the clockwise direction, and the magnitude of the moment of T1 will be T1 into B. So writing the moment equation, we have P into L plus T2 into A minus T1 into B will be equal to 0. So P and T2 are having positive moments and T1 is having the negative moment. So from here we can have P is equal to T1B minus T2A upon L. Now as T1 is greater than T2 and also B is greater than A or A is less than B, then under all conditions P will always be positive. So under all conditions the effectiveness of the brake will depend upon the force P. So these are the various cases of differential band brake, and depending on the value of A and B you have the value of P, and accordingly the effectiveness of the brake is depending on the value of A and B and also on the direction of rotation of the drum and the direction of application of the force P. Now moving ahead, let's compare all these results. So when A is greater than B, so P should be acting downwards. For the counterclockwise rotation of the drum, this is the relation of the applied force, and for the clockwise rotation of the drum, this is the equation for the load applied. Similarly, when A is less than B and P should be acting up in the upward direction, so in the counterclockwise direction this is the relation, and for the clockwise direction this is the relation. The condition of self-locking in case of A is greater than B is T2 by T1 should be less than B upon A, and this will be obtained in the clockwise rotation. And the condition of self-locking in case of A is less than B is T2 by T1 is less than equal to A upon B, and this will be obtained in case of counterclockwise rotation as shown here. Having seen the condition of self-locking, we should understand where the self-locking is required. The advantage of self-locking is taken in hoists and conveyors where the motion is permissible only in one direction. If the motion gets reversed somehow, the self-locking is engaged, which can be released only by reversing the applied force. Now, having seen all these relations, we should now discuss about the effectiveness of the differential brake. The brake is said to be more effective when maximum braking force is applied with the least effort P. For the case 1, when A is greater than B and P is applied in the downward direction, the effort P required is less when the rotation is clockwise, assuming that the brake is effective. And similarly, for the case 2, when A is less than B and the force P is applied in the upward direction, the effort P required is less when the rotation is in the counterclockwise direction, assuming the brake is effective. So, in case of A is greater than B, clockwise rotation will be more effective, and in case of A is less than B, counterclockwise rotation will be more effective. Now it is seen in the above discussion that the differential band brake is more effective only in one direction of rotation of the drum. However, a two-way band brake can also be designed which is equally effective for both the direction of rotation of the drum. In such a brake, the two lever arms are made equal as shown here. So these two arms are made equal, and in all the conditions this configuration will be equally effective. So for both the rotations of the drum, the applied force will be T1 plus T2 into A by L. So this is all about the differential band brake. I hope you have understood the various configurations of the differential band brake and the equation of the applied force P, and also the conditions of self-locking in case of differential band brake. I also hope that you have understood the criteria for effectiveness of the differential brake. So this is all for today's lecture. In the next lecture, we will solve some numerical problems based on differential band brake. In case of any doubts, feel free to contact me. Thank you.